Okay, I've tried to make this video twice, and it's given me fits like every time. So hopefully this is the last time. Let's take negative 2 times x minus 3 square plus 2. Now what I want you to do is first recall the table of values for the parent function y equals x squared, because we're dealing with a quadratic there. Negative 2, negative 1, 0, 1, 2. That is supposed to be a 2, is 4, 1, 0, 1, 4. Negative 2 squared is 4, negative 1 squared is 1, so on and so forth. And let's go ahead and graph that. 0, 0, positive and negative 1, 1, positive and negative 2, 4. And we'll go ahead and make our parabola. Awesome. So, if you're going to want to do this graphically, that's fine, but you need to make sure you follow order of operations. So first we're going to do what's in parentheses. Now this means we're going to move right 3, because remember that's an h value, and anything inside the parentheses is going to end up being opposite. So negative 3 means move right 3. So let's move all of our points to the right 3. And there, I've done it. All of my points have moved to the right 3. Great. And so I'm not going to draw the parabola each time because my graph will get cluttered very, very quickly. So now that we've done that, the next thing to do is multiplication. Now, you could multiply each one of these the y values of these red dots by negative 2, and it would be just fine. But in order to show step-by-step motion, I want to first reflect it, because of this negative, over the x-axis. So this point right here, oh, I'm moving it everywhere. This point right here is 1, 2, 3, 4 away from the x-axis. So to reflect it over that axis, we want to go 1, 2, 3, 4 on the other side of the x. And you want to do that with all of these red points here. So let's just do that. This one's 1 away, so it goes 1 away over here. And go on. That one's on the x, so it will stay on. And so this shows how the graph reflected over the x-axis. So let me get rid of the red here, because we've already done that, and it's not really any good to us anymore. So now we have a graph that's moved over to the right and reflected over the x. So now let's stretch it. So we got to multiply each of these values by 2. So this value is at 0, or I'm sorry, let's do like a different color, like purple. This value is at negative 1, 2, 3, 4. So it's going to go 4 more spaces. We're going to double it. So you're going to double all of these. It's 1 space away, so it'll be 2. 0 doubled stays 0. And how do we know if we stretched it correctly? Well, if I connect my blue dots to make a parabola, and then I go back and also connect my purple dots, you can see that the purple is in fact skinnier, meaning it's been stretched. So that's a pretty good way to check to make sure you've done it correctly. So now I'm going to erase my blue, because you don't really need them anymore. So I've done everything there is to do except for one last step, and that is move it up 2. So I'm just going to take all my points and move them up 2. Excuse me, I'm not feeling the greatest. And so I'm going to go ahead and erase the purple because we don't really need it anymore, and connect my dots here. And so what we have, or what we've created, is a graph of our parent function y equals x squared that's been stretched, moved to the right, moved up 2, and then reflected over the x-axis. Now, if you are a graphical person, a visual person, and you like doing it this way, great, that will get you there every single time. I'm more of an algebraic person, and so I like to do this in a more algebraic manner. So I'm going to make a new xy table. I noticed that anything that happens in parentheses with this x is going to affect the x. So I know that I need all of my x values here to move to the right 3. So I'm going to do that. How do I move to the right 3? Well, I add 3 to it. So negative 2 is right here. To move to the right 3, I just go 1, 2, 3. So I'm going to do that with all of my values in the table. So negative 2 plus 3 is 1, 2, 3, 4, 5. I've just moved all my x values of my parent function to the right 3. Now this is cool because now if you're a person who likes to plug and chug, like substitute, you can just take these x values, substitute them in for x up there, and get new y values, and you should be in the clear. Perfectly okay to do. I don't even like doing that. So I'm going to take this orange here, and I'm going to apply everything that's outside of parentheses, these two things, and apply them to my y values. So I'm going to take all my y values, multiply them by -2, and after I do that, add 2 to them. Times -2, and then add 2 to them. I'm going to do that all the way down. And so 4 times -2 is -8, plus 2 is -6. And 1 times -2 is -2, plus 2 is 0. 0 times -2 is 0, plus 2 is 2. And then 1 again, so 0, and then 4 again, so -6. So hopefully these are the ordered pairs of my points over there. Let's check. 1, -6, 2, 0, 3, 2, 4, 0, 5, -6. And we have liftoff. That's the way I prefer. I don't really care how you do it. Just know how to analyze this. And finally, before you quit on me, the domain of this function, the leftmost it goes is -infinity, the rightmost it goes is infinity, or all reals. Let me do that a little better. All reals. And then my range of this function, the lowest it goes is -infinity, and the highest it goes is 2, and it includes that 2, or y has to be less than or equal to 2. Hope you enjoyed my video. See you later.